Hi, everybody. Welcome back. This is Math 70, and this lecture video is section 4.6. It turns out that the previous video I combined 4.4 and 4.5, which the name of the video has, but the actual lecture video, I don't think I say that I cover 4.5. But anyway, we're covering 4.6 in this video, which is dimensional analysis and scientific notation, which are both versions of rules of exponents. Dimensional analysis is a fancy word or fancy phrase for changing units of measurement. So for example, if I have 12 inches, that's the same as 1 foot. I've just changed the units of measurement, which is the same as 1/3 of a yard. So I can change inches into feet. I can change inches into yards. I can do it a lot of different ways. And the key in order to do this is to have a table that gives you different dimensional conversions. So I'm going to just jot down a table that we're going to use here. So let's do 1 foot equals 12 inches. 1 yard equals 3 feet. 1 mile equals 5,280 feet. 1 inch equals 2.54 centimeters. Let's see, 1 meter equals 100 centimeters. And 1 kilometer equals 1,000 meters. And I could continue. All of these are distance measurements, but there are similar ones for weight, like 1 pound. Actually, I should do it the other way. 1 kilogram equals 2.2 pounds. And let's say 1 pound equals 16 ounces, etc. So this table that I'm going to use is all in distances. So how to convert units. So let's take 48 inches and convert to feet. I have a way that I'm going to recommend you use because it's flexible and it can handle all sorts of different types of conversions, especially the much more complicated conversions that you will get into both later in this section and in future math courses or other work that you may do. So the way I recommend is you write down your initial amount and then you multiply it by your conversion factor. So this table gives me conversion factors. It says there are 12 inches in 1 foot. So I'm going to write that conversion factor, and I'm going to be very careful to say if I start with inches, then I want to end with feet. So I use my conversion factor with foot on the top and inches on the bottom. And now I multiply and I cancel. 48 inches times 1 foot, that's 48 times 1. And this inches in the numerator and the inches in the denominator cancel. And the 12 in the denominator stays there. And so I get 48 over 12 feet, which is 4 feet. let's do another example. Let's convert, let's say 180 yards to feet. So I start with my original units, or my original quantity. And if I'm converting from yards and I want to end up in feet, I'm going to put feet in the top. And I go to my table, and my table says there are 3 feet in 1 yard. So I'm going to have 3 feet in 1 yard. There's my fraction. This time the yard units cancel, and I get 180 times 3 feet over the 1, which is 540 feet. If you use this approach where you look at your initial units of measurement and change them to your ending units of measurement, that will keep the conversion factor in the right order, top and bottom. Okay, let's do one that's a little more challenging because it's going to involve multiple steps. So let's convert 200 yards to miles. So again, I start with yards, and I want to end with miles. But if I look at my table, I don't go from yards directly to miles. I have to go through feet first. I have to go from yards to feet and then to miles. And that's what I'll do with the conversion. So first I'm going to convert to feet from yards, and then I'm going to convert to miles from feet. And I wrote my units first to help me remember my order of conversions. There are 3 feet in 1 yard, and there are 5,280 feet. So I write it in the bottom because that's where the feet are, to 1 mile. And now I can just do my multiplication and my cancellations. I'm rewriting this so I can do those cancellations. The yards cancel and the feet cancel, leaving me with just miles as my unit. And I have 200 times 3 times 1 divided by 1 times 5,280, which is 600 over, oh, I forgot my units, miles, which is 600 divided by 5,280 miles, which is about 0.114 miles. I started with yards. I went through feet to get to miles. Okay, so far, we've just been converting distances. We haven't really used the idea of exponentials at all, but now we're going to convert volumes instead of inches. So let's convert I'm just gonna pick 400 inches cubed to centimeters cubed. So what's that saying is I have some shape. We can think of it as an actual cube. There we go. And the volume is 400 inches cubed. Right, so the space inside this cube is 400 inches cubed. And we want to know what would that same volume be. Oops. If it were in centimeters cubed. Well, all we need to do is remember our first rule of exponentials, which is exponential is repeated multiplication. So if I have 400 inches cubed, that means I have 400 inches times inches times inches. And I want to convert it to centimeters cubed, so I want centimeters times centimeters times centimeters. And each centimeter is going to cancel with one of the inches. Inches cubed to centimeters cubed means I'm going to need this conversion factor 3 times. There are 2.54 centimeters in an inch. And so I just need to have that conversion factor 3 times. And here's where our exponentials come in. Inches cubed on top are going to cancel with the 3 inches on the bottom, leaving me 400 times 2.54 times 2.54 times 2.54 centimeters cubed, which we would usually write as 2.54 cubed. And I'll get an estimate for what that number is. 2.54 cubed 400 times 2.54 cubed is about 6,555 centimeters cubed. So the volume inside this cube is 400 inches cubed, which is equivalent to 6,555 centimeters cubed. Let's do another one. Let's convert, how about 5 square meters to square yards. A meter and a yard are pretty similar in size. A meter is just a little bit bigger than a yard. So if I have something like this, where the area now is 5 meters squared, I want to know if it's yards squared, what's the area going to be? So I start with 5 meters squared, so I'm just going to write that as meters times metered. And I want to end with yards squared. But unfortunately, again, if I look at my table, I don't go directly from yards to meters or vice versa. I go from meters to centimeters and centimeters to inches and inches to feet and feet to yards. So I'm going to have a lot of different multiplications to do, but you just need to chase through. So to remind myself, I'm going to go from meters to centimeters to inches to feet to yards. So the meters times the meters is going to convert into centimeters times centimeters, which is going to convert to inches times inches, which is going to convert to feet times feet, which is going to convert to yards times yards. Unfortunately, I ran out of room, but I'll rewrite it again when I do the actual calculation. So I have 5 meters times meters, and then there are 100 centimeters in 1 meter, and I have to do that twice. And then there is 1 inch to 2.54 centimeters. And I do that twice. And then there is 1 foot to 12 inches. And I do that twice. And finally, there is 1 yard to 3 feet. And I do that twice. And now I can check my units. Meters, meters, cancel. Centimeters, both of those cancel. Inches, both of those cancel. Feet, both of those cancel. And I'm left with yards times yards. So I know that I got my multiplication factors set up correctly, my conversion factors. So I have 5 times 100 times 100, and then I'm gonna do a lot of division, divided by 2.54 times 2.54 times 12 times 12 times 3 times 3. And that's going to give me yards squared. And this is what calculators are for. That's going to be 50,000. And I need a calculator to do all of this math. So let me grab a calculator here. 2.54 times 2.54 times 12 times 12 times 3 times 3 is about 8,361 yards squared. And then I'm going to get that fraction and I'm going to get a decimal approximation. And I get 5.98 yards about yards squared. 5.98 yards squared. So 5 square meters is equivalent to almost 6 square yards. And that's how you carry around unit conversions. You just make sure that if you have a square meters, then you need to match up the meters twice or the units twice in any conversion as you multiply across. All right, let's do one more. And we're going to add another table of information here. We're going to say, well, it's common to go from seconds to hours. So there are 60 seconds in 1 minute and 60 minutes in 1 hour. So let's convert 10 meters per second to miles per hour. Right? People run, and we often call it meters per second and running. Miles per hour is how we often think about speed for things like cars or bicycles. So it's very common to convert from one speed to another speed in terms of units of measurement. But we're still going to set this up in the exact same way. I want to go from meters to hours. So to get that, I'm going to have to go, based on my table, I'm going to have to go through centimeters to inches to feet to miles. And the seconds, I want to go to hours, and I have to work through minutes. But once I know the order that I'm stepping through my units, I can write all of my multiplication factors down. I'm going to add one little piece of information that's going to help me is 10 meters per second is 10 meters in 1 second. So I'm actually going to write that 1 in front of the seconds. And now I'm going to convert meters to centimeters. So I want centimeters here and meters there, and there are 100 centimeters in 1 meter. And I'm going to convert centimeters to inches. And there's 1 inch in 2.54 centimeters. And now I'm going to convert inches to feet. And 1 foot is 12 inches. And then I'm going to convert feet to miles. There's 1 mile and 5,280 feet. That took care of the distance part. And now I just have to take care of the time part. So here's a second. And I want the denominator, instead of being in seconds, I want to convert it to minutes. So now I put the 60 seconds on top is equivalent to 1 minute. And now I want to convert the minutes to hours. Oops. So I put the minutes on top and the hours on bottom, and there are 60 minutes in 1 hour. So you can do this all in one long chain, or first you can convert the distance and then you can come back and convert the time. But let's just look at the time piece. Here I had 1 second in the denominator. and I want to have hours in the denominator. So I take my seconds, and now I do 60 seconds per minute, and that's going to cancel out the second in the denominator at the beginning with this second way over here. And then the minutes cancel right next to each other, and it leaves me hours in the denominator, which is what I want because I want miles per hour. And then I'm also going to come through and cancel all the distance units one by one, and I end up with miles. So I have all my conversion factors laid out, and now I just have to multiply. So I have 10 times 100 times 1 times 1, 1 times 1 times another 1 times 60 and times 60. 10, 100, 1, 1, 1, 60, 60. And divide all of that by 1 times 1 times 2.54 times 12 times 5,280 times 1 times 1. 1, 1, 2.54, 12, 5,280, 1, and 1. This is going to give me miles per hour. And I grab a calculator to help me do all that multiplication. Ten times 100 times 1 times 1 times 1 times 60 times 60. It's a super big number, but I'm going to end up doing the division. It's 36 with 5 zeros. That's 3.6 million. And then the denominator is 2.54 times 12 times 5,280, which is 160,934.4 miles per hour. And I'll get a decimal approximation for that. And it actually works out to be a very reasonable 2.4 miles per hour. Sorry, 22.4 miles per hour. So, you know, a very fast human running 10 meters per second is going about 22 miles per hour. All right, that wraps up the dimensional analysis part. But this section also covers scientific notation. Which is another way to write powers of 10. So let's just review our powers of 10. 10 to the first, well, that's 10, because that just means 10 with no multiplication. 10 squared, 10 times 10 is 100. 10 cubed, 10 times 10 times 10 is 1,000. 10 to the fourth is 10,000. And notice there's 1 0, 2 zeros, 3 zeros, 4 zeros. All right, so 10 to any power, call it P for power, will be a 1 followed by that many zeros. By the way, at Google, the number, which is spelled a little different than the search engine, is 10 to the power 100. Is that number right there. 1 followed by 100 zeros. It's inconceivably large. It's larger than the number of atoms in the universe. But it's not so bad when you can write it as an exponential notation. All right, so let's take this and use it to write big numbers a little more easily. For example, if I wanted to write 34 thousand, I could say, oh, well, that's 3,400 times 10. That's not much more useful. Or 340 times 100, or 34 times 1,000, or 3.4 times 10,000. And this is what we're going to use for scientific notation. We're going to say any number can be written as a decimal between 1 and 9.999 repeating times 10 to a power. And that is exactly what scientific notation is. It's the fact that any number can be written as a decimal between 1 and 9.999 times 10 to a power, like 223418. I can write that as a decimal times 10 to a power. This one I have to multiply it by, let's see, 100,000. Oh, but I'm getting lazy, so I'm going to write that as 10 to a power. This is called, I think, expanded notation. And this is scientific notation. It's just a way that mathematicians get a little bit lazy. And we're like, since I'm already working in the decimal system anyway, decimal means 10, I might as well use that to my advantage. So the question becomes, what power do I use? And the way you do that, or the way you figure it out, is you count how many steps the decimal point has to move. So let's look at my two examples. 34,000. We don't write it with the decimal point, but if I did, it would go right there. And in order to get it written as 3.4 times 10 to a power, I have to move the decimal 1, 2, 3, 4 steps. So it must be 3.4 times 10 to the fourth, because the 4 steps becomes the power. And 223,418, I'll just stick that decimal point at the end. And I move 1, 2, 3, 4, 5 steps. So it becomes 2.23418 times 10 to the 5. That's how you write any big number in scientific notation. Here's a silly example. How do you write 8 in scientific notation? Well, 8, the decimal point's already right there, so 0 steps required. So it must be 8 times 10 to the 0. That's their scientific notation, and that makes sense because 10 to the 0 is 1. And let's look at, how about 40? Well, here I have to move it 1 step, so that's 4 times 10 to the first. So now let's look at small decimals. Let's look at 0.000724. This, according to my rules of scientific notation, This is a number that can be written as a decimal between 1 and 9.9 times 10 to a power. So I should be able to write it as 7.24 times 10 to some power. How do I pick the power? I count how many steps. 1, 2, 3, 4. 4 steps, but now it's 4 steps left. That means the power is negative. 7.24 times 10 to the minus 4. So we can write really big numbers and really small numbers in exponential notation. Let's just do another example. 0.00318. I should be able to write it as 3.18 times 10 to a power. 1, 2, 3 steps left. It means the power on 10 is a minus 3. We can also write fractions, certain fractions in exponential notation. For example, if I wrote 724 over 10,000, well, that's actually, let's use our exponential notation. 724 divided by 10 to the fourth, which is 724 pause. All right, that's the video. Thanks for watching.